Write the equation of circle centered at 0, 0. We talked about that. You probably have a note card somewhere that has that equation on it. Get y by itself, which turns out to be a little bit of a difficult sort of, not real bad. So I get y squared equals 25 times x squared. Any questions about getting y by itself? Well, I haven't done the derivative yet. Just got y by itself. Is this equivalent to 5 minus x? No, don't do that. So now, if I want to find dy dx, what would that be? Any questions so far? Oh, just a little bit of simplification. The 2's cancel, so I get plus or minus negative x over the square root of 25 minus x squared. Now the next question is one that we haven't asked a lot, but we've asked a couple of times. We will spend a whole day on it on Tuesday, but we're going to kind of pull those in occasionally even before then. Use that derivative to find the equation of the line tangent at the point 4, 3. Well, what do you need for a tangent line? You need the slope and a point, right? And the derivative is the slope. So I just need to plug in 4 into this equation. Okay. Questions so far? So if you plug in 4, you get the notation for this is dy dx at x equals 4 is equal to negative 4 over the square root of, what's 25 minus 16? Plus or minus 4/3. Well, I'm going to go look at the picture really quick. That tangent line at the point 4, 3 is negative, isn't it? And it's slanted down. Where did this equation come from? Point slope form. You want to know and love point slope form because you get to leave it that way. It's hard to convince 8th graders how great point slope form is. It looks like more.
Why did we understand between different uses?
Oh, you use all of them. And graphing, you know, it's not mx plus b is nicer, but you need to know them all. Any questions about this? Yes, you're right. General form of a line is the least useful, but sometimes they write them right into it. Okay. One more slide on tangent lines, writing tangent lines. Again, we're going to spend a day going over this a little bit more. Quick overview of a tangent line. To find a tangent line, I need 3 things: x, y, and m. Slope and an x and a y value. So I'm going to find those 3 things. On this problem, it says find the equation of the tangent line 2f of x at x equals 3. So what's x? 3. Easy question. What is y? I gotta find out, right? Plug in 3 into the original equation. 9 minus 15. Yes. Is everyone okay with how I found that? They didn't give me why, I had to find it, but too terrible. And m, how do I find m? Man, aren't so glad you don't have to do the derivative the long way anymore. Do you have a question? No, you have a question? Oh, okay, answer it. Any questions so far? Y minus negative 3, which is y plus 3, equals m times x minus 3. Equation 2. This is the exact same equation at the bottom. And it asks me to find what's called a normal line. For now, you're just going to have to go with me and say, okay, a normal line is what she says it is. A normal line has applications in physics. It is the line that is perpendicular to the tangent line. That's it. So if they ask you to find a normal line, you just want a perpendicular to the tangent line. Well, I'm going through the same point, right? So I'm still going through 3, negative 3. I just changed the slope to be what? Y negative 1. Opposite reciprocal. Perpendicular lines, you change the sign and you flip it. Does that make sense? Change the sign and flip. So it's y plus 3 equals negative 1 times x minus 3. That's what a normal line is. Find the slope of the tangent line, flip it, and make it negative. Opposite and reciprocal. Any questions about tangent and normal lines? What we're going to spend the rest of today doing is trying to make the bell ringer problem easier. Would you agree that bell ringer problem was a little bit challenging? Pretty nasty derivative. Are y'all okay on this? Yeah, we're just making sure. Okay, so I have two questions up here. The first one is one of the easiest questions I could ask you, right? What's the derivative of x to the 4th? I found the derivative of x to the fourth, and this d dx means with respect to x, right? Well, that's what we've always done, is found the derivative of x with respect to x. The second question asks me to find the derivative of y with respect to x. Well, what is y normally? Right, a function, right? It's got a bunch of x's in it. So if I take the derivative of y to the fourth, it is 4y to the third, but what would I have to do knowing that y has a bunch of x's in it? So let's pretend y is 3x squared plus 5. And
then you have to do the chain.
and do the chain. So the only difference in taking a derivative of an x term with respect to x and taking the derivative of a y term with respect to x is the chain rule. Chain rule, right? So we're going to do times dydx. It stands for, remember y is something like this. It would be 6x. Right.
Would you still put that in for y?
Well, I don't know what y is. I made this up. I don't know what y is.
But if you say it,
Yeah, I'm not going to know what y is.
I don't understand. So you just do the dy over dx.
I'm going to leave it that. Like, this is the answer. Yeah, I just put y.
This might be a bad question, but what is the difference between maybe the d over dx and the dy?
This is the derivative of x to the fourth with respect to x. This is the derivative of y. So, this is what's called implicit differentiation. So, this d over dx is the derivative of x to the fourth with respect to x. This one is the derivative of y to the fourth. This is the derivative of x to the fourth. This is the derivative of y. So the y is the x to the fourth.
So if it gave you a function like y equals, like the top one you wrote, would it say dy dx?
It would.
But because that one's just
Right, just x. Okay, so I want to do the derivative of x plus 5y. Remember, the whole game is to keep in mind apply more to it. I don't know what y is. I'm not going to know what y is. I'm not going to teach you what y is. I don't know. But I know it has more to it. It's not just a y. It's some function of x, like it always is. So what is the derivative of x? 1, like it always has been. What's the derivative of 5y? 5 times whatever the derivative of y is. This can also be written in Newton notation at a 1 plus 5y prime. Either way. Again, the big thing is I don't know what y is, so I have to know that I have to do a chain rule there. And the next one, read that to me. Say that louder, Patrick. Okay. Why am I asking you to do that? Left. D right. What's the derivative of y? The derivative of y, right? It doesn't. dy over dx and y prime equally good.
If that was my y,
So that's lefty right plus. Now, let me, just because I know some of you really want to do it, what would happen if I did put this down? What is dx over dx? 1. So that's why we don't write it. If you're asking yourself that question, why haven't we been writing this the whole time? Well, the derivative of x with respect to x is just 1. So it's just unnecessary to write. Any questions about these?
The d is just the derivative of the whole thing, and if dx is on the bottom, it means that it has to be like d and x's, and if it's dy on the bottom, it has to be with d, so that's why that's dy over dx, because it's the derivative of just y.
Right. Well, we've never had a y on the bottom, so. And we won't for a long time, because changing y over changing x gives a slope. Now I want to revisit the bell ringer. Okay, remember to do this, to find the derivative of the bell ringer, I had to get y by itself, and I had to do a really nasty chain rule derivative. Y'all remember? I'm now going to take the derivative, what is called implicitly, using what I learned on the last slide. I'm just going to do the derivative of the whole equation. So what's the derivative of x squared? What's the derivative of y squared? And what's the derivative of 25? I now want to get dy dx by itself, right? I wanted the derivative. Which one's easier? This is easier, right? Now let's go ahead and answer the whole question from the bell ringer. It said to find the equation of the tangent line through the point 4,3, right? I need the slope. Just plug in 4 and 3 and for x and y, right? What would I get?
When you get the dy over dx, it's just sitting down like y.
So dy dx can be defined as what's called implicitly, and this is the implicit definition. Now, if you really wanted to see that they were completely equivalent, you could solve for y and put it there, and you would get the square root of the 25 minus x squared on the bottom, and you would notice that's the same. Thank you, Ted.
So you get dy by itself, the dy over dx.
Just get the dy dx by itself, not the y. You're trying to find y. Speaking of steps to do implicit differentiation. Step 0. Do what? I would write this down. I am no longer officially making you do note cards, but this might be something that you might want to have handy. Step 0, it's not really a step because you don't have to do anything. But imagine that y is some function of x. We just don't know what it is. Step 1, take the derivative of both sides using the chain rule every time you take a derivative of a term with a y in it. Step 2, collect all the y prime or dy dx terms, depending on which notation you decide you like better, on one side of the equation, and solve for y prime. Hint, you're always going to want to factor out the dy dx's or the y primes. If a question asks you about a specific point, plug it in.
Are we doing derivatives for the rest of the year?
Yeah.
So when
We'll have the mastery test. You weren't here yesterday, were you? We will have a mastery test next week. And then, so far, and then the week after, you'll have another, the second part to that mastery test. It's actually going to be a 50-point test, where the first 50 points is the mastery test, the second 50 points is actual test. So it works out nice for you, point-wise. That will be your 9 weeks test. All of it together.
That's all.
That's the goal. That is the goal. If nothing else, the mastery exam will. But my goal is to get the whole test on this. Turn that air down. And just don't change the stop. Just put the temperature down. So, find the derivative of x squared y cubed minus 6 equals 5y cubed plus x. Now, if you were ever questioning why we would want to do implicit differentiation, this should give you a y. Do you want to solve for y in that problem?
No.
I don't either. So we're not going to. But you don't have to. We can find the derivative without solving for y. On the one on the bell ringer, we at least could. Some of these will be so difficult that you couldn't even if you wanted to. This one you could, but some you can't. So I'm just going to take the derivative as it sits. Before I start, I'm going to read the question to myself like Patrick did earlier. X squared times. I know that's a little unnecessary, but I'm going to do it because what am I picking out? Product rules. Anytime you see an x and a y sitting side by side, you need a product rule. Minus 6 equals 5y cubed plus x. I only need one product rule, right? Left. So I'm doing the derivative of this. D right. Times what? Good. dy dx or y prime. That is a personal preference difference. If you prefer to write y primes, do it. If you prefer dy dx's, do that. My hint to you is if you have bad handwriting, use dy dx's. The little primes, you'll lose them. If you have nice, pretty handwriting, y prime is quicker to write. So that would be my hint to you on which one you should choose. I have bad handwriting, so I use dy dx more often. I know you don't see that up here, but when I'm working problems on my own paper, they look like yours. Left d right, left right, d left. I don't need a dy dx on that one because I didn't take the derivative of y. What about the 6? Goes away. 15y squared dy dx plus 1. So I've done step 1. Step 2, collect all the dy dx terms on one side. Doesn't matter which side, just put them all on one side. I'm going to go to the left, but so I have 3x squared y squared dy dx minus 15y squared dy dx equals 1 minus 2xy cubed. Does everyone see what I did there? Subtract. Dy dx is on the left, non-dy dx is on the right. Does anyone have a question about that? Dy dx is on the left or right, it doesn't matter which side. Factor out a dy dx. You will get to where you do this step and this step in one step together. When you move, you'll just factor out the dy dx as you move it over. You can. Definitely can. But the main thing I need to do is get dy dx by itself. So you definitely could though. And then divide by the 3x squared y squared minus 15 y squared. It's yucky, but that's the derivative and I'm done. Yes, sorry. Oh, so you can see the bottom, sure. You don't have to. Now, if you are matching a multiple choice question, you may have to do a little manipulating here and there. One thing I do want you to watch out for on multiple choice is if your top and your bottom both are negative compared to their answer, that's the same thing. Do you know what I mean by that? Because you could factor out a -1 or multiply the top and bottom by -1. The way that happens is moving to a different side of the equation than whoever else solved it. So if you ever see a multiple choice answer that's identical to yours except every sign is different, then that's it. You just went to a different side of the equation. Any questions about this one? Okay, let's do a few more. That's what you're trying to get by itself.
last sentence.
Or this is it for this tonight anyway, Claire. It's actually due Tuesday. Because they won't quite finish the lesson. I think chain rule is one of the hardest things you do in semester 1 calculus. I was teasing my calculus classes today or yesterday that I was mad that chain rule fell on the day that y'all had to pick classes for next year because they were going to chicken out on me, and they were like, "Yeah, that would be a bad time." So even the first time doing chain rule is just a tough thing. So I think it was a tough one. No, you'll get to where chain rule is easy, but for some reason that first time you learn it, it's a tough one. X times y equals -1. I want to take the derivative of that. And remember, I read it. X times y, so I need a left, d, right, and just for my y prime people, I'll work this one with y prime. Get all the y primes on one side.
Why is this? Why is it x, y prime?
Left, d, right. If you do, use it. I'm pretty flexible. Any questions about that? Okay, a little bit yuck here. Do you see any products? Mental note that. I've got a product here and a product here. There are a lot of different ways that you can look at this. My hint to you is to group the constant as your left-hand piece. Just make it part of your left-hand piece. The -3x squared is one piece. Most of the time, if you don't do that, you'll forget the negative or forget the 3 somewhere. You could factor out the -3 and then distribute it in, but people forget it a lot that way, so just consider it part of the left-hand function. Okay, so the derivative of x cubed is, and I'm just going to put a plus there because I'm going to deal with the negatives in the product rule. Left, which is -3x squared, d right, plus right, d left. Does everyone see what I mean by grouping that negative in as I go? That's the way I like to do it. Just be careful with that negative. Any questions on that one so far? The first product rule. Left, -3x squared, d right, y dx, plus right, which is y, d left is -6x. Left, d right, plus right, d left. And the derivative of 12 is 0. Group all my dy dx terms on one side. I'm going to go through and underline those in blue so you can see them. I have this one and this one. I'm going to put those on the left. You don't have to, but just one way to do it. Are you okay if I go ahead and factor out a dy dx as I put them on the left? 4xy minus 3x squared. You could do -3x squared plus 4xy if you prefer. All the others, I'm going to move to the left or to the right.
So if we did the other side of the problem, our signs are the opposite.
which is not a problem at all. So, let me underline in green the ones I moved to the right. And notice there's a sign change on all of those because I subtracted them over. Bottom shelf. And there's a seat in between where you can sit in that chair and use the box. Any questions on this one? So what I did is I practically considered this plus negative 3x squared. And I just thought of it as negative 3x squared. Right. And that's the way I do it. Now you could factor out a negative 3 and then do a product rule on the x squared times y and then distribute the negative 3 back in. It would get you the same thing. Yes. It's best if I was supposed to let me get you one thing and then I'll let you leave. We'll probably stop there for today. Pick up here tomorrow. I do have one other thing you need to start to work on. The implicit differentiation is due Tuesday. Of course, chain rules due Monday. It was technically due today. I am also going to pass out your first mastery exam for calculus. This is the take-home copy. I'll give you the answers to this on Monday, so if you want to work through it this weekend, you can. If you want to just get the answers on Monday, that's up to you. Tuesday, we'll start taking this. Okay. It's due the 13th, which is not Friday next week, but the next Friday. It's a quicker turnaround than I like. I've thinking about it several times. I decided you would probably rather get it in on the Sunday. So, 2 weeks. So it's a little bit of a quick turnaround, but when I was making my decisions, I decided most of you wait till the last week to do it. Just the last week. No, there's another week before spring break, but the 9 weeks ends on the 13th. We'll take it in class on Tuesday, and then you can take it anytime after that. Monday, I'm going to give you the answers to this one. Okay, any questions?